Okay, our next example, Innocent Investments, this is on page 496 of the book, is like a very simple portfolio planning example. We have a set of kind of funds that we can actually put our money in. And we want to distribute, we've got $500,000 and we want to distribute it between these funds. Now, what we want to do is here, we're setting our targeted return. This is a trade-off between risk and return. Now, what we do is we say for 5% return, expected return, what's our minimum risk? We could have done this the other way around and set our, what risk we would actually have, and then try and get the maximum return for that level of risk. But for the moment, for this example, we've got a target return of 5%. We need a return of greater or equal to 5%. And we're actually trying to minimize the risk for that return. As I said, we need to invest $500,000. We need to invest $200,000 in income, equity, and balanced on basically those two funds. And we also have a series of constraints. We can't put more than $200,000 in any one fund, and we have to put a minimum of $50,000 in the multinational and balanced funds. So I guess we have a set of policies for creating these funds, but we have some degree of flexibility once we've kind of met with all these policies. So the first thing here, and again, I've done what I've done on all of these, is that I've removed some of the calculations from the initial spreadsheet, and then we'll do them myself. So as this is going to be a constraint equals $500,000, we want a sum of the amount invested. These in red, orange are the decision variables. Now we also want our kind of weighted risk and weighted return measures. So what we're going to do here is basically we're going to do a sum product of the amount invested, and what was the first one was actually risk, and the risk. Now, to get this in terms of actual percentages, we're just going to divide, because this is a weighted sum of the amount we invested. If we divide by the amount we invested, then we'll just get the aggregate weighted risk. And it's going to be the same with the weighted return. So it's going to be sum product, expected the amount invested, comma, expected return, divided by the total amount invested. Now let's just make sure I haven't messed that up. That's risk is in column D, return is in column C, and each time we're sum producting with the amount we invest. And this one's very simple because we're going to make it the last two to add up to $200,000. We basically have the last two, C24 and C25, and we're going to constrain them to be $200,000. So now we actually have enough to create our solver. So what do we want to do? Well, we want to minimize risk. So we want to minimize risk. By changing all of these. And we have quite a few constraints, so let's just kind of put them in order. Okay, sorry about the phone. Where were we? We just set the objective. So the objective here would be to minimize risk for a certain value of return by changing these cells. So we need to add some constraints here. So let's just first add the investment constraints. So the total that we invest has to be equal to $500,000. Okay? The total calculated versus $500,000. Then we also want Our last two, income, equity, and balanced, is equal to $200,000. We'll add that. And what we want to also do is very important, our kind of weighted return. So in this instance, we are minimizing risk for a certain level of return. That certain level of return is at least 5%. Now, it's important we actually do this and don't try and write 5%. Otherwise, we could get a problem of scaling, of comparing 0.05 with 5%. So let's add that one in. We've also got our maximum constraints. So all of these have to be less than or equal to all of those. And we've got our minimum constraints. All of these are greater than or equal to all of those. Okay, and we don't need to do this one because basically greater or equal to 0 is in these additional constraints, but some of them are 50,000. Okay, so the other one last thing we're going to do is we're doing a simplex options, and we're going to click or use automatic scaling. That just makes it a little bit more, it just makes the algorithm a little bit more flexible. Particularly here, we're dividing by values. So rather than the total target return, we've got weighted returns. So use automatic scaling allows Excel to try and find the best way of scaling the data, but it will always kind of transform back at the end. And then I think that's pretty much it. Okay, so we've got a total of 50,000. We've got a risk of 6.41 for a weighted return of 5%, greater than 5%. We've got 50,000 low price stock, 50,000 multinational, 200,000 mortgage. Then we also have income, equity, and balance. We don't have anything in the mid cap. And we could actually play around with this a little bit. So say we could do a what if analysis. So say we had a weighted return of 6%. Then I guess we'd have to take on more risk. So I'd imagine that our risk would be greater than 6.41, but let's just play around. And there we are, risk is 6.99 if we want a return of 6%. Now let's go back to 5%. And let's add some of the answer reports and sensitivity reports. So again, the answer report just summarizes what we said. We have the final value from the previous, tells us which constraints are bound and which constraints are not bound. So of course, some of these maximum and minimum constraints are not bound because we're not at the maximum or minimum. The total amount invested is bound, so we invest 500,000. Same with the amount invested in the last two items because we set it equality to be equal to 200,000. Where was that? Total amount invested. Oh, so the income equality, that's going to be bound because it's equal to 200 thingy. The mortgage amount is bound because we've invested the maximum. Mid cap is not bound on the maximum, but for example, it's bound on the minimum as we don't have anything and the minimum is 0. So that's the constraints. And the sensitivity analysis, this one actually is quite interesting to me, the shadow price for their constraints. So the weighted return is 0.05, i.e. 5%. So this is just saying for any increase, and it's hard because the increase is this is quite a small value, but for the increase in weighted return, this is how much the risk would kind of incrementally increase. So if we'd want to say, rather than run the solver, if we wanted to kind of estimate a little bit of what would happen if we incremented weighted return, then we could utilize this shadow price. Now, the sensitivity analysis is very difficult to interpret. Now, the reason it's difficult to interpret is basically, remember, the reduced cost would be the change in the objective value required to either add something to the solution or remove something from the solution. Now you see that these values are very small, and that's basically because the objective coefficients are very small. It's because we're in the objective here, we're weighting it by the total investment, so we're dividing it by $500,000. So that's why to actually interpret this, you would probably have to multiply all these coefficients by $500,000, and then you could interpret them in terms of the level of the risk. But again, it's not really covered in the book, but I'm just doing this as extra. We did the kind of the portfolio analysis. We played around a little bit with things like this, the kind of the targeted return. And we were trying to find the minimum risk for a certain level of return and building an optimization model.